previous discussions, we learned that the x and the y components of a projectile are independent to one another. However, there is one quantity that is commonly used by these components, and that is time. In this video, we will analyze how time connects the x and the y components of the projectile. Which will fall faster? Object A dropped directly from a height of 2 meters, or Object B, identical to Object A, that is flicked from the table of the same height. The answer to this is neither of the two, because they fall at the same time. Seems confusing, right? Maybe some of you have guessed that the one dropped directly will fall faster, since it covers a lesser distance, or the one flicked horizontally strikes the ground first, since it moves faster after a force is applied to it. Unfortunately, these guesses are wrong. How about those who have guessed right? Can you explain this? Let's take a look at this. In your discussion about freefall, the object starts from rest, which means that its initial velocity is 0 and gains speed at 9.8 meters per second every second as it falls. The object falls because of the Earth's pull of gravity, which is always directed downward. What we mean by downward here is the direction towards the center of the Earth, wherever you are located around the world. Now let's use the freefall concept in analyzing this. When the object is launched with a horizontal velocity from a certain height, it moves forward at a constant velocity while it's moving downward at increasing velocity, giving the combined velocity indicated in the violet arrow. Obviously, the horizontal force that is applied to the object is the reason why it moves forward. On the other hand, gravity is what causes this object to move down. Without the action of gravity, the object will continue to move in a straight line in the horizontal direction, so it will not fall. The horizontal motion is what causes this object to cover a certain range at a given time. The time taken by the projectile to cover this range is dependent to the time taken by this projectile to reach the ground when it falls, because the projectile can no longer move forward if it has already hit the ground. Therefore, the time in the x component is limited by the time in the y component. In other words, the time taken by the projectile to cover the vertical distance is equal to the time taken by this projectile to cover the horizontal distance, as long as the vertical and the horizontal distances intersect at a common point. This concept is the same when the projectile moves up at angle projections. It's just that the velocity of the projectile in going up is decreasing every second by about 9.8 meters per second, because as it goes up, it gradually loses its energy due to the continuous pull of gravity opposing its direction of motion, until it reaches the maximum height, where this object momentarily stops before going down. So, while the object is moving up, it's moving forward at the same time. The time taken by the projectile to cover half of the range in the whole parabola is equal to the time it took to reach the maximum height, and the time taken by this projectile to reach the ground is equal to the time it took to cover the other half of the range in the whole parabola. Thus, the projectile's time of flight in the horizontal projection is equal to the time it took to cover the downward displacement, while the time of flight of the projectile launched at an angle is the total time it took to move up, reaching the maximum height, and down where it lands.